Hello everyone, hope you all are doing well. So in this video, we'll discuss the last problem of Leetcode BiWeekly contest 104. It's a hard level problem. The problem name is power of heroes. So it says that you are given a zero index integer array nums representing the strength of some heroes. The power of a group of heroes is defined as this. Okay, let I0, I1, Ik till Ik be the indices of the heroes in a group. Then the power of this group is the maximum element among these elements. Which elements? Nums of I0, nums of I1 till nums of Ik whole square into minimum of the same elements, right? Nums of I0, nums of I1 till nums of Ik. Okay, return the sum of power of all non-empty groups of heroes possible. Since the sum could be very large, you return the answer modulo 10 raised to power 9 plus 7. Okay, so what does this mean? This means that, in short, I'll tell you using a brute force what the problem statement says. So you are given an array. Okay, you generate all the subsequences. Okay, what is a subsequence? Okay, so subsequence is basically you select every possible combination of the elements, right? For example, you have 2 1 4. So what will be the subsequence? It will be 2 1 4, 2 1, 2 4, 1 4 and 2 1 4. These are the subsequences. Got it? So these are the subsequences you generate, and now for every subsequence calculate the power. What is the power? For example, if my subsequence is 2, so the power is whole square of the maximum element. Here maximum is 2, so whole square of 2. Then what is the minimum element? It is 2, so you just multiply it by 2. Okay, it is basically max square into min. Like for example, for 2 1 4, what is the max element? It is 4, so 4 whole square into what is the min element? It is 1, so that is 1. So for all these subsequences, generate the powers and add them, and that is your final answer. This is what the problem is trying to say. Okay, now for n elements, how many subsequences, or rather I would say subsets, you can generate? You can generate 2 raised to power n subsets. Okay, so 2 raised to 10 raised to power 5. Why? Because I have 10 raised to power 5 elements, so the number of possible subsequences that I can generate is this. And obviously this means that a brute force approach will not work here, right? So I'll have to do some I'll have to use some other techniques, right? So let me explain you with the help of a concrete example. Okay, so I will just erase it and I'll just pick it up. Yeah, got it. So suppose, okay, suppose I have an array, so 1 2 4 3, something like this. Now the first thing here is the order of the elements in the array doesn't matter when you have to generate the subsequences, right? For example, 1 2 4 3 will generate the same subsequences, same set of subsequences, which will be generated by 1 2 3 and 4. Okay, got it? Because obviously the number of subsequences here will be 1 2 4 3, then you have 1 2, then you have 1 4 1 3 and so on. So similarly the same subsequences will be generated by what do you call it, this as well, right? So I'll just delete it. So in short, to simplify my solution, I'll sort the array. Okay, I'll sort the array. Like for example, I'll make it 1 2 3 4. Why I will sort the array? Because or rather let me tell you afterwards. Okay, now suppose I consider the first 3 elements. Okay, I consider the first 3 elements, 1 2 3, or let's assume this as x. Forget about 3, let's assume this as x. Okay, now since this is sorted, okay, suppose this is sorted, so for whatever subsequence I generate which has x, okay, so this is my last element, so I have to include it, and I can either include these 2 elements or not. It is totally optional. Like for these 2 elements, they are optional, but I have to include this, right? Now let's see what will be my contribution. Okay, what will be my contribution? So if I am considering 1 to x, so what will be my maximum element? It will be x. Okay, it will be x. What will be my minimum element? It will be 1. Okay, it will be 1. What are the other subsequences that I can generate? So if I have 1 to x, I can also generate 1 and x. I can generate 2 and x, right? For these 3 elements, what are the possibilities? I can generate these 3 things. Obviously the last one is generating only x, so for right now just skip it. Okay, just skip it. So in this case, what will happen? Again, my max is x and my min is 1. Here my max is x, my min is 2. Now I'm trying to show you a pattern, right? I'm trying to show you the pattern. So what happens here is if I have 1 2 and x, okay, and look, for every element, taking that single element is a subsequence. So for right now, that skip it, consider the other subsequences, right? Like for example, first pick 1 2, then pick 1 then 2, right? So these are the possible three values, three subsequences you can have. So here, if you consider these three elements, just see how many times. So every subsequence has max as x, but how many times you have min as 1? 2 times. And how many times you have min as 2? Just 1 time, right? Now let's extend it, right? Let's extend it. Suppose I have elements 1 2 3 and x. I have like this, okay? Now I'll generate the subsequences for this as well, okay? So for this, max is x, okay, and min is 1. Now what are the other subsequences I can have? I can have 1x, I can have 1 2x, 1 3x, okay, yeah, then I can have 2x, 2 3x, I can have 3x, and obviously 1 is x. I'll not take it, right? I'll not take it. So I've taken 1, I have to take x, right? I've taken 1, I've taken 1 2, I've taken 1 3, then I've taken 2 3, and I've taken 2 as well and 3 as well, right? So these are the possible subsequences that you can have, right? You have to always take it, and you have to take either of the elements, right? Now just see what happens here. The max is x, min is 1. Max is, in everyone, max is x, min is 1, min is 1, min is 2, min is 2, min is 3. Now just see the pattern here. How many times you have 1 as min? 1 2 3 4, 4 times. How many times you have 2 as min? 2 times. Getting it? This is what you do. And how many times you have 3 as min? That is 1 time. So just see, these are powers of 2. These are powers of 2. What I mean to say, in the previous step, 1 was acting as min 2 times and 2 was acting as min 1 time. Now as soon as I include one more element, 1 is acting min as 4 times, which is double of the previous step, and 2 is acting min as 2 times, which is again double of the previous step, and 3 is a new element. So obviously I'll be taking this, right? So what I am trying to tell here is that suppose these are the 3 elements. So whatever is the contribution of these elements, right? Whatever is the contribution of this element, like for example, now if I talk about the score of this array, so what will be the score? It will be x square into 1. This will be x square into 1, and so on. So if you consider everything has x square as a common thing into, just find the sum of all these. So sum of all these is 1 plus 1 plus 1 plus 1. That is 1 coming 4 times, 2 coming 2 times, and 3 coming 1 time. Okay, getting it? This is what I mean to say. So the maximum element is fixed here. That is the last element. Okay, if I'm considering this sub array, okay, for example, I've sorted the array. This is my array. I'm standing at the ith position. This is my max element. What about these elements? These can act as min elements depending on which subsequence I choose. Okay, so if I find out the contribution of each element, I can just add it and multiply it by whole square of this one. So then I know the score of all those subsequences which end at x, okay, which end at x, and all the possible combinations are covered. Getting it? So x square is taken as common, and I add all these. Now in the next step, what will happen? In the next step, ultimately, these will be coming 8 times, 2 will be coming 4 times, 3 will be coming 2 times, and the new element that you have will be coming 1 time. So power of 2. This is what we mean to say. Getting it? So now if I come back here, so what I will do, or let me just show you here only. Okay, now I'll take a concrete example. Suppose my array is 1 2 3 4 like this. So let's start calculating it for index number 0. Okay, what are the two possibilities? So in the previous explanation, what did I tell you? We are considering all the subsequences except the one which has only a single element, right? Now we'll consider that as well. Why we were omitting it? Because after we have calculated the answer for the ith step, I'll be including it into my contribution for the next step. Okay, it will not be included right now. Okay, so now just see, this is 1, so the max will be 1 and the min will be 1. So the answer will be 1 square into 1. Okay, This is the case when I'm considering only this element, right? Now what is the case where I'm considering previous element as well? So till now you don't have any previous element. Your variable is initialized by 0, and what did I say? Whatever was the contribution till previous step, it will be multiplied. So it will be previous into 2, previous equals to previous into 2 plus the current element, because now this will be contributing in the next step. So this one, okay. Now let's consider two elements. So this is 1 and 2. Now when I consider 1 and 2, what are the possibilities? Let's only see when I have only one element. That means I only consider a subsequence which has 2. So the max is 2, min is 2. So answer is 2 into 2 into 2. That means you add this in your answer. So initially your answer was 1 here. Now your answer becomes 1 plus this, that is 9. This is your answer. Now consider the subsequences where this is acting as maximum, and all the previous elements can be taken, can be omitted. Okay. So now in that case, what will happen? The value in the previous is 1. The value in the previous is 1. Now again, it will be if I consider 1 and 2, so my max is 2, my min is 1. So it will be max into 1. Okay, max into 1. So now my answer will be 9 plus this. 9 plus this. And this actually is the previous count. Whatever is the answer, 13 is the value. Okay. Now what I'll do? I will do previous equals to previous into 2 plus the current element, because now this current element will also be contributing as a min element from the next step. Okay. So now if I take 1, 2, 3, so what will happen if I consider only this element? So it will be, so my answer was 13, right? So it will be 13 plus 3 into 3 into 3, max square plus min. Okay. What about the previous elements? It will be max into max. What is the sum of min elements till now? So the sum of min elements till now is, so previous was 1. So it is 1 into 2 plus 2. That is 2 plus 2, 4. So this is 4. 3 3 is 9 into 4, 36. Okay. This is the one. Now you multiply previous by again 2. So previous equals to previous into 2. You are doing it for the next step. Add the current element as well, because this will be contributing from the next step, and all the other elements which are present till here will be multiplied by 2, because now they'll be forming more subsets, right? That will be multiplied by 2. So that's it. You'll be performing these steps. Okay. And finally, in this way you'll be calculating the contribution of each element, right? Again, the logic here is, you're standing here, ith element, you have to see in which all subsequences this guy is acting as maximum. So one subsequence will be considering only this element, and the other subsequences will be considering the previous element as well. So if I consider the previous elements, in some subsequence this will act as min, in some this will act as min, in some this will act as min, and some this will act as min. In every of them this will act as max. Okay. So we are finding the contribution of each one of them. Like for example, in how many subsets this guy is acting as min, in how many subsets this guy is acting as min. So this is the way you find the number of subsets. Okay. So that's it for the solution. If I show you the code, it's very easy. I initialize my answer with 0. I sort my array. Previous contribution is 0. Now what you are doing? Answer equals to answer plus num into num into num. This is the case where I am considering only the current element. So max into max into max, right? You have only single element, plus max into previous contribution. That means what is the contribution by the previous elements? That means the elements on my left hand side who are acting as min elements in different subsets. Okay. And you are taking proper mods. Okay. Because at every particular point of time it can overflow, right? You multiply two elements, these are of long type. I've converted them into long because the range can be 10 to the power 9. As soon as you do multiplication, it can go up to 10 to the power 18, right? So that is why I've done mod. You multiply it, you take mod, again this number comes in a range of 10 to the power 9. You multiply it by this, it goes into 10 to the power 18, but as soon as you take mod, it comes into a range of 10 to the power 9. Then again you are adding, this goes to 10 to the power 18, taking mod, it comes back to 10 to the power 9. Again you multiply previous contribution, that goes to 10 to the power 18, take mod, it comes into range of 10 to the power 9, and so on. So that is why we are taking mod after a pair of multiplication. Okay. Finally, what you do, previous contribution equals to previous contribution into 2 plus the current number, because now the number of subsets will be multiplied by 2 and the current number will also be added so that it contributes in the future subsets. Okay. and finally you return your answer. So yeah, that's it for this problem. This was a very good problem, I would say. A better version of the contribution technique that you generally use in these types of problem. Okay, so I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. Also, in case of any queries, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.